Any answer? Good evening. Oh, very good, Shahid. Arif, Faiza,
Yes,
Madiha.
sir. Doing 1 minute.
Okay, very good, Madiha. Very good. Faiza, have you got the answer? Yes or no? Okay, just take 2 more minutes and let me know. Whoever solved the first one, please do solve the question number four. Second, this fourth. Faiza, if you are facing any kind of problem in solving this, just let me know. So this is for question number 1, right? Very good. Go for question number 2 on the right hand side. Yes, M is molality. Okay, I'm going to explain this. If you're not able to solve it, don't waste time. Just let me know so that we will be able to solve more and more questions. What is the mole fraction of solute in 1 m aqueous solution? First of all, 1 m, this m stands for molality, and 1 m is, we can write 1 mole per kg, 1 mole per kg. And you know that in molality, this per kg is mass of solvent, mass of solvent. And per kg, that means mass of solvent is 1 kg. Also, you can see here that it is in aqueous solution, that represents that the solvent is water. That means indirectly it is given that mass of H2O is 1 kg, or you can write 1000 gram. And this is your mole of solute. Mole of solute. How we know about this? Because you know that molality is equal to number of moles of solute upon mass of solvent in kg. Mass of solvent in kg. And you can see 1 mole per kg, that means moles of solute is 1, and mass of solvent is 1 kg, that means 1000 gram. And since it is in aqueous solution, so it will be water. Now we need to calculate the mole fraction of solute. Mole fraction of a solute will have a formula: number of moles of solute upon number of moles of solute plus number of moles of solvent, and solvent is your water. Now you can see number of moles of solute is given as 1 plus number of moles of solute again given is 1. And how you are going to calculate the number of moles of solvent, that is water, given mass upon molar mass. Given mass upon molar mass. Just wait a minute. Given mass upon molar mass. Given mass of water is 1000 gram and molar mass is 18. So it will be 55.5 if you are going to solve it. So after solving this, you will be able to get 56.5, which will be approximately equal to 0.0177 mole fraction, and mole fraction doesn't have a unit. So this will be your mole fraction of solute. Is that clear, everyone? Faiza, Muhammad Harif, Shahid, Madiha, and Faiza joined. Please do respond. Very good, Madiha. Very good, Faiza. I'm gonna give you another question. If you are facing any kind of problem in concept, just let me know. This is another. Everyone done with the previous question? Question number 4. Very good, Madhya. Please do this question. Everyone done with this? Yes or no? No one is responding. Shahid, Faiza, Tarif. Okay, Madhya. Take your time. Yes, very good, Madiha. What about you, Arif? Shahid? Shahid, am I audible to you?
Yes, sir.
Okay, Faizal.
Continue to do this.
Yes, yes. Shahid, very good. Arif, any answer for this question? No, Faizal, did you excuse me for a minute? Shahid and Madiha only gave me the answer of question number 8. Yes. So you have to understand what does this question says or which type of question is this. You can see you have two containers. The first container which contains which has one molarity and volume is 2.5 liter in NaOH. Now solution is mixed with another 0.5 m and 3 liter NaOH solution. Then find out the molarity of resultant solution. So basically you are calculating the molarity of mixture. So molarity of mixture has a formula M1V1, whatever, let's say this is your M1 and this is your V1 and this is your M2 and this is your V2 plus M2V2. If you have another container, then you are going to write M3V3 as well upon V1 plus V2. M1, as you can see, 1 and this V1 is 2.5. M2 is 0.5 and V2 is 3 liter upon V1 is 2.5 plus V2 is 3 liter. So you can see this will be your answer 2.5 plus 1.5 upon 5.5 upon 5.5, and you can easily calculate this. So as you can see, this is your 5.5 and after adding it, you will be getting 4 upon 5.5 m. And if you are going to divide this 4 divided by 5.5, you will be getting 0.727 m. That means 0.73 m we can say. And hence the answer is C for question number 8. Have you got it? Arif,
Yes,
This
sir.
formula I didn't know, sir.
what did you say, Savage?
Sir, I actually didn't know this formula was there.
Okay, okay, no problem. So whatever you are learning new, or if you don't know the formula, just write it and make a star on it. Very important. These are some previous year's question of NEET. I will also give you some questions from JEE as well. But first we are going to cover the very basic conceptual questions. And I'm going to remove this. Please do let me know when you are done with question number 8 so that I'm going to move this 9 to a little bit down and then solve it. Are you done with question number 8?
Yes, sir.
Anyone done with question number 9? Yes, yes, exactly. See, I'm going to explain this. This question is quite easy. Only density is given. Density is given as 1.17 gram per centimeter. Cc means per centimeter cube. Cc means centimeter cube. And this is about HCl. This is about HCl. I'll just check it, Madiha. I think you are right. Now see, density is equal to mass upon volume. And if you are going to write it 1.17 gram upon 1 centimeter cube. Can I write this as this? Because you know that gram is the unit of mass and like this. And now, as you can see, what you need to do? We need to calculate molarity. Molarity as a formula, number of moles of solute upon volume of solution in liters. Now, number of moles of solute, how you are going to get it? This is the mass of HCl. This is the mass of HCl solution. So number of moles of solute you can easily calculate given mass upon molar mass. Given mass is 1.17 and molar mass of HCl. Cl has 35.5 and hydrogen has 1. So 36.5. And also if you are going to calculate the volume you can see 1 centimeter cube, but we need to convert this into liter. So you are going to divide it by 1000. This will be your in liter. Now you are just going to put the value number of moles of solute 1.17 divided by 36.5 divided by volume of solution 1 upon 1000. If you are going to solve it, you will be getting 32.05 m. So the answer that you will get will be B. Oh, very good, Shahid and Madiha. Be confident about your answer, whatever you get, Madiha. There is always question mark in your answer. Are you getting my point, Madiha?
Yes, sir.
Okay. I'm gonna give you another conceptual question. Everyone done with this question? Yes or no? Please do this question number 10. This is a very easy question based upon mole fraction.
Sir,
Yes,
in ninth question, 1.17 was the given mass.
yes. And this is your molar mass.
Yes, sir.
Yes, Tharif, but you have to use this formula to calculate number of moles. And then you can divide it by 1/1000. Tharif, have you got this? Yes or no?
Yes, sir.
Just let me know if you are facing any kind of problem or doubts in this. Now you are going to solve question number 10. Tharif, is this for question number 10?
Yes, sir.
It's wrong answer. X mole fraction is always non-negative. It is true. We need to,
Sir, I sent.
yeah, I'll just check it. Just wait a minute. Tharif, it's wrong. And yeah, it's correct. Saviz, Tharif, listen here carefully. Mole fraction will be always lesser than or equal to 1. It cannot exceed 1. And the value of mole fraction usually lies between 0 to 1. Values of mole fraction usually lies between 0 to 1. Are you getting my point, Arif?
Yes, sir.
So you can see in the option first, mole fraction is greater than 0 or equal to 0 and less than 0, less than 1 or equal to 0. It is true. Mole fraction here equal to 1 or less than 1. It is also true. Mole fraction is always non-negative. You know that mole fraction will have value between 0 to 1. So it will be always non-negative. It cannot be negative. And if you are going for D, mole fraction here, it has been written less than equal to -2, which is wrong. Mole fraction will always have value in between 0 to 1. So the answer will be D. Okay. Everyone done with this?
Sir, D is the option, right? Correct.
Yes, D is the right option. And someone has sent C and D. Shahid, C cannot be the answer. X is always non-negative. It is true because the X represent mole fraction, and mole fraction has a value 0 to 1. Is it negative? Is there any number which is negative in between this, Shahid?
No, sir.
Okay. Now we are moving to the next topic, that is ideal and non-ideal solution. Everyone has revised this chapter, right? I already told you to revise in the previous class, because in this special class we are going to solve only questions. So this is my first question on ideal and non-ideal solution. Please do it. I want answer from everyone. S, you don't know S? S is entropy. Oh, it's wrong answer. Very good, Madiha. Wrong answer. Okay, I'm gonna explain. And be honest to yourself. Just let me know,
It's
everyone.
volume, right?
No, no. Just let me know one thing. Have you revised this chapter? I want answer for this question from everyone. Shavez, have you revised this chapter? Yes or no?
Sir, it did, sir, but ideal and non-ideal I have to revise first.
No problem. You read? Okay. Harif,
Yes, sir.
did you revise?
Sir, I didn't revise ideal.
You didn't revise ideal and non-ideal?
Yes, sir.
Faiza, Shahid, okay, no problem. I'm not going to give up next question on ideal and non-ideal. I'll give up to Rawls law. Okay. By the way, this question is very, very easy. You know, this is your ideal and this is your non-ideal, right? In between, I will explain the concept also, as I told you. In ideal, I told you delta V mix will be equal to 0. Delta H mix will be equal to 0. The force of interaction between AA and BB after mixing, they will be equal to the force of attraction of AB. When you are coming in non-ideal, delta V mix not equals to 0, delta H mix not equals to 0, and the force of interaction between separate particles will not be equal to the solution particle. Now there is another important thing. It follows Rawls law. Rawls law. If it follows Rawls law, that means P absorbed will be equal to P calculated. And if this P absorbed pressure will be equal to calculated pressure, then if you are going to calculate delta P, it will be equal to 0. Yes or no? Because it has been written here, it is for an ideal solution. In ideal solution, the pressure, absorbed pressure, is equal to calculated pressure, and if you are going to subtract that, since they are equal, the value will be 0. Yes or no? Arif, Shavez,
Sir,
everyone.
Yes, sir.
So this will be equal to 0. Ideal solution, you can see delta V mix 0, delta H mix is also equals to 0. But when we are going to talk about delta S or delta G, always remember whether the solution is ideal or non-ideal. It will be greater than 0 or it will be less than 0. This criteria is same for both ideal and non-ideal. Got it? So you can see delta S mix greater than 0. So according to the question, which one is not equal to 0 for an ideal solution? That is delta S. Got it?
yes.
Okay, Madhika and everyone. Just give me. Okay. Now I'm gonna give you a question on Rawls law, and I hope you will be able to solve it. Take your time. The calculation is a bit not hard, but it will be in decimal. So this is the question. Molar mass and everything is given. Please do this. No, I haven't got your PT is equal to P naught 1 plus P naught 2 minus P naught 1. I haven't got it the this. You can write in a paper and then send me. Arif. Okay.
Yes, sir. Well connected.
Hmm. Any answer? Very easy it is. Okay, let's say I'm gonna explain this. You can see vapor pressure of chloroform and dichloromethane at 25 degrees centigrade. Individually, it has been given chloroform CHCl3. That means pure vapor pressure of chloroform, that is 200 mmHg. And it has been also given that pure vapor pressure of dichloromethane as 41.5 mmHg. Now you can see vapor pressure of solution obtained by mixing. We need to calculate vapor pressure of solution, that means PT, total pressure. And you know that total pressure will have a formula, that is partial pressure of chloroform plus partial pressure of dichloromethane. And accordingly, you can write the formula from the Raoult's law. Partial pressure of chloroform will be equal to pure pressure of chloroform into mole fraction of chloroform, plus again partial pressure of dichloromethane will be equal to pure pressure of dichloromethane into mole fraction of dichloromethane. Now you can see P naught CHCl3 is given as 200. You need to calculate only the mole fraction of CHCl3, and that will be equal to number of moles of CHCl3 upon number of moles of CHCl3 plus number of moles of CH2Cl2. And how you can calculate the number of moles? It is also given. You can see here that 25.5 gram CHCl3 and 40 gram CH2Cl2. So you can easily calculate number of moles of CHCl3. Given mass, that is 25.5, upon molar mass, that is also given as 119.5. So you can calculate this and put the value here. And again, number of moles of dichloromethane, that is given mass as 40 and molar mass is also given as 85. And again calculate the value and put it here, and you will get the value of mole fraction, and you can put here. In the same way, this quantity is given, and you accordingly you can calculate the mole fraction and put it here, and you can easily calculate. I hope everyone got it. Is there any doubt? Shawez, Arif?
No, sir.
Okay, please do solve it and let me know the answer. Am I audible? Am I audible to all of you? My system got
Yes, sir.
okay. So any answer for this question as I gave you the hints about this? Any answer? Faiza, Madiha,
So
okay.
still doing.
Okay. Also remember the option here is not correct. Okay. So don't match your option uh, in this four. Okay.
Yes, sir.
Let me know when you are done with this. Madiha, any answer? Chavez?
So 1 sec.
Okay. I'm waiting. Chavez, the answer is 90.9, 91. It's not 32.3. Have you calculated the value of PT, pressure of the total pressure or pressure of solution, or you have calculated only the first part? You need to calculate this as well as this and then add them both.
Sorry, sir, by mistake I did it.
Okay, what's your answer? The new answer?
90, sir.
90. Very good. It will be almost 90 point something, that is 91, near to 91. Shahid, Arif. Okay, I'm gonna just show you and you are going to calculate it at home. 200 into, if you are going to put the value here, 25.5 upon 119. Wait a minute. If you are going to solve it, you will be getting 0.21 here. And if you are going to solve this, you will be getting 0.47 here. So what you need to do, 0.21 upon 0.21 plus 0.47. So you just need to multiply it with this and you are going to add this as well. 7 plus 1, 8, 4 plus 2, 6, 0.68 plus P naught CH2 Cl2 as a value that is 41.5 into mole fraction of this, that will be equal to 0.47 upon 0.68. And after solving it, you will be almost getting equal to 91 mmHg. Is that clear, everyone? Shahid, Tharif, Faiza, Madiha.
Yes, it's clear. Yeah.
Okay, thank you. Moving to the next question. That is similar to this one. Just wait a minute. Question is very easy if you have got the concept in this previous question. So you can easily solve this. Please do it. You know, pressure has different units like Pascal, mmHg, torque, Newton per meter square. So don't afraid of this. Torque is the unit of pressure. Let me know when you are done with this. Oh, very good, Chavez. Madiha, Shahid, any answer? Taviz, you can go for this question as well. Madhya, very good. Tharif, what about you?
Sir, I have difficulty with that one.
Okay. Should I explain, Tharif? Very good, Taviz. Shahid, any answer for this question? Okay, just calculate it. The calculation in this question is not tough. It will be cancelled easily. No, very good, Shahid. Shahid. Arif, have you got the answer?
Yes, sir, train.
What is the answer? A, B, C, D? Shahid, you can go for this question. Very good, Shahid. Arif, what is the answer for this question?
Sir, I don't know. I'm not getting it.
Yeah, I'm gonna explain. Just focus here. It has been written the vapor pressure of two liquids P and Q that is given as 80 and 62. That means the pure vapor pressure of P is 80 torr and pure vapor pressure of Q is 62. Okay. Also, the total vapor pressure of solution obtained. We need to calculate total vapor pressure of solution if number of moles of P is 3 and number of moles of Q is 2. Now what we need to do is very simple. To calculate total vapor pressure, that will be equal to partial pressure of P plus partial pressure of Q. And partial of pressure of P will be equal to pure pressure of P into mole fraction of P plus partial pressure of Q will be equal to pure pressure of Q into mole fraction of Q. Now pure pressure of P is given as 80 into mole fraction of P. Mole fraction of P, you can easily calculate number of moles of P, that is equal to 3 upon total number of moles. That means 3 plus 2, that will be equal to 5. So you are going to multiply it by 3 into 3 by 5 plus pure pressure of Q. Pure pressure of Q. Wait a minute. This is your P. Pure pressure of Q, that is given as 60 into mole fraction of Q, that will be equal to number of moles of Q upon total pressure, that is 5. So you are going to just solve it, simplify it, you will get your answer. This will be cancelled by 16 and 16 3 is 48 plus this can also be cancelled by 12 times and 12 2 is 24, and if you are going to add it, you will be getting 72 and the answer will be A. Is that clear, Harif?
Yes, sir.
Okay. So please do this question. Everyone is done with this question as well. A molar solution is one that contains 1 mole of a solute in, you know that molality has a formula that is equal to number of moles of solute upon mass of solvent in kg. Mass of solvent in kg, that means per kg 1000 grams. So 1 mole of a solute in 1000 gram of solvent. So I think it's clear to all of you, right? Arif?
Yes, sir.
I'm going to give you this again a question. Please do this question. Very important question it is. Molarity of ions. Okay, I'm going to explain this. Tharif, any answer?
Sir, I'm doing 1 minute.
Okay. Shavez?
Sir, I'm doing.
Faiza, are you done with the above two questions? 72 torr and the one on molality, right? Faiza, you are not responding. Okay, so please do respond as fast as you can. Let me know if anyone is having problem in solving this. It's very easy. Okay, let's start. I'm going to explain this. See, 25.3 gram of sodium carbonate, Na2CO3, is dissolved in enough water to make 250 ml of solution. First of all, if sodium carbonate dissociates completely, see, this is your sodium carbonate, and if you are going to dissociate it completely, it will be converted into Na plus CO3 minus 2. And to balance it, you have to multiply it by 2. It's very simple. So in order to calculate the concentration or molarity of this ions, in order to calculate the concentration and molarity of its ions, you need to calculate the molarity of the parent compound like this. Okay, you need to calculate the molarity of this first. So someone has sent me the answer. Who is this? Mohammed Harif. Harif. Okay, it's good. Correct. Now see, to calculate the molarity of this, number of moles of solute upon volume of solution in liter. Now, in order to calculate the number of moles of solute, just wait a minute. In order to calculate the molarity of the solution, number of moles of solute, given mass 25.3 upon molar mass, that is given 106, divided by volume of solution 250 in liter. So we need to divide it by 1000. Now what you need to do, 25.3 divided by 106, that will be equal to 0.24 divided by, you can see, 250 divided by 1000, that will be equal to 0.25. So if you are going to calculate this, 0.24 divided by 0.25, that will be equal to 0.9696 m. Now what you need to do, if you have calculated this, you need to see the stoichiometric coefficient of this. So you can see the stoichiometric coefficient of Na2CO3 is 1 and Na plus is 2, and for CO3 minus 2 is 1. So you just need to compare it. 1 will give 2. So the molarity of Na plus will be 2 into 0.96, and 1 will give 1. So molarity of this will be equal to 0.96. If you are going to multiply this 0.96 into 2, that will be equal to 1.92. So you can see 1.92, that is approximately equal to 1.91. And the next is 0.96, that is approximately equal to this. So the answer is B. Is that clear, everyone?
Sir, can just one second explain that.
See, what information given was about this. So you just need to calculate the molarity of Na2CO3. You can do that because mass and volume is given. So you can easily calculate the molarity of Na2CO3. Yes or no, Shavesh?
Yes, sir.
And after calculating the molarity of Na2CO3, you are going to dissociate this electrolyte. So this will be converted into Na plus, not plus 2. Na always goes in plus, and CO3 carbonate in minus 2. And you need to balance it. So you need to multiply it by 2. Now it is balanced. Now you are going to apply the stoichiometric concept from class 11th. And what is that? What is the coefficient? In maths, we say coefficient. What is the coefficient of x square? That is 1. What is the coefficient of x cube? That is 2. But in chemistry, we say it stoichiometric coefficient. So if I'm going to ask you, what is the stoichiometric coefficient of Na2CO3? That is 1. What is the stoichiometric coefficient of Na plus? That is 2. And what is the stoichiometric coefficient of CO3 minus 2 is 1. So in terms of mole, you can say that 1 mole of Na2CO3 will give 2 mole of Na plus. 1 mole of Na2CO3 will give 2 mole of Na plus and 1 mole of CO3 minus. In the same way, you can say 1 molarity of Na2CO3 will give 2 molarity of Na plus and 1 molarity of CO3 minus 2. Are you getting my point?
Yes, sir. Yes, sir.
So since you get 0.96, so 1 is giving 2, so 0.96 will give you 0.96 into 2. 1 will give 1, so 0.96 will give 0.96 m. So this is the molarity for Na plus and molarity of CO3 minus 2. Is that clear, everyone?
Yes.
So please do write it. This is the last question for today's session. I'm going to tell you the topic that.
Sir, can you just scroll up?
Yes, yes. Just wait a minute. It's very simple. The molarity of ions are very simple.